understand about section 14-1, type of mixtures. So after you listen to my presentation, you'll be able to solve the examples and know the vocabularies. So the heterogeneous mixture is a mixture that does not have a uniform composition and individual substances remain distinct. So as you can see the diagram, you can see that the circles are kind of in kind of random organization and does not have any uniform composition, which makes a heterogeneous mixture. And there's suspension, which is the mixture containing particles that settle out if left undisturbed. So example is sandy water. Because when you mix sand and water, you can it can mix, but after you settle for like a minute or so, you can see that the sand kind of settles down and the water and the sand kind of remains unmixed. So yeah, it's suspension. And then colloid is heterogeneous mixtures of intermediate sized particles, meaning that there's solution, colloid, and suspension, meaning the solution is the smallest and the colloid is the next smallest and the suspension is the largest, which is between 1 nanometers and 1000 nanometers and does not settle out. And it has the most abundant substance in a mixture is the dispersion medium. So this means that you can see the diagram, there are positive and negative particles, and you can see that the negative particles are the majorities in the diagram, which means the negative is the dispersion medium. And then the colloids are categorized according to the phases of the particles. And the Brownian motion is a random movement of particles in a liquid colloid from the result of particle collisions. And the example is the dust particles. So you can see, so just imagine that this is dust particles and this is air particles. So like imagine you're in the dark room where the air is still and there are bright lights streaming from the window. And you can see that the dust particles are visible. And then the dust particles do not move downward but moving in all directions. And this is because of the Brownian motion. Because the air particles are moving in very fast speed and they move in collision with the dust particles, so the dust particles kind of collide with the air particles and move in all directions, which means they move in like a random directions.
Mm-hmm.
And there's a Tyndall effect. So Tyndall effect is dispersion colloid particles scattered light. And kind of to explain more, it is a scattering light as a light beam passes through a colloid, and the individual dispersion particles scatter and reflect light, making them invisible. You can see there's a laser beam kind of going to a pure water and colloidal solution. So in the pure water, there's no particles moving and colliding. So you can see a laser beam passing through. However, in the colloidal solution, because there is particle kind of making the beam collide and scatter lights, you can see them invisible in the colloidal solution. So this is an actual experiment. So in the water, you can't see the light kind of shining through. However, that water is the water mixed with soap. Because there's particle inside, you can see that the beam is kind of visible because all the particles kind of colliding with the light particles, making the light particles kind of scatter light. And the next is a homogeneous mixtures. So the solution is a homogeneous mixture that contains 2 or more substances called solute and solvent. Does anyone know what solute and solvent is?
No. No.
Okay. So solute is so as I said in the Yunju, do you know?
응?
Do you know solute and solvent?
물이랑 섞이는 거랑
So as I said in the colloid section, there's dispersion medium. So because dispersion medium is the majority of particles, so in this case, solvent is the dispersion medium and the solute is the small particles inside. And you can see the particles are organized and it's moving. It is organized in patterns, which makes a homogeneous mixture. And most solutions are liquid, but there is gases and solid solution. And then there are types. The soluble means a substance that dissolves in a solvent. So are, for example, the chocolate milk. So when you mix the cocoa powder in the milk, you can see that the cocoa powder is dissolved in a solvent, which makes the chocolate milk. And then there is miscible, which means two liquids that are soluble in each other in any proportion, and there is no solute or solvent. An example of this is a carbonated water plus orange juice. You can see that the two liquids can be mixed together and make that water plus orange juice liquid. And then there's insoluble, which means a substance that does not dissolve in a solvent. And the example is sand plus water. Sand plus water. As I said in the previous slide, when you mix sand and water, it can mix, but when you leave it for the while, so you can see that the sand particles kind of settle down and do not mix together. So that is example of insoluble. And the next is immiscible, which means two liquids that can be mixed but separate shortly after. The example is water plus oil. So like when you mix, it can mix, but when you leave it for a while, you can see that the oil kind of goes to the top and the water kind of goes bottom, which kind of makes it impossible to mix. Thank you.